say, my name is Andrew, and I used to be a developer. God, I feel like a weight of the world lifted off my shoulders coming out of the closet like that at an OWASP conference. But it's okay, I'm one of you guys. I'm not a developer anymore. I'm a security guy. I'm one of you guys. I don't know if any of you noticed when Martin introduced Troy yesterday, he said that he was a developer, used to be a developer, and there was silence through in the room. And then he also made the suggestion that actually we don't need security folks. The world should just be full of developers who know about security. And there was complete silence. But as I say, I'm no longer a developer, still do a little bit of development, but mainly security testing now. So topic of my talk is about Android WebViews. I've got quite a few slides to get through. So some of the slides I'm going to race through. I'm going to try and do some demos, live demos. They're rather simple demos, so in case things go wrong, I want to give myself a chance to get those working. So a little bit about me. My name is Andrew Lee with one L Thorp. I do security testing. We do mobile. We do Android. Lots of mobile. There's my email address. So here's the agenda. I want to do a little bit about some WebView basics. And then I've picked what I think are 4 fairly important topics we need to consider when we talk about Android WebViews. So I'm going to talk about the JavaScript interface, the WebView sandbox, HTTPS, and a little bit about handling other schemes. So firstly, what is a WebView? A WebView is basically a control to display some HTML content inside your app. And it allows the app to react to various events, like web events, events that affect the browser. Pre-KitKat, WebView, Android WebView was largely based on WebKit. And KitKat and later WebView is Chrome-backed. There's still a little bit of WebKit, in fact, a fork of WebKit core in Chromium, but largely the WebView is being weaned off WebKit. And the latest development in WebView land is that since Android Lollipop, the WebView comes as a separate APK, which means you can update it separately through the Google Play Store. Whether the user chooses to update it or not, I guess is up to them. So it's worth taking a step back and just considering for a moment what are the threats in WebView land. So on the left, I have a traditional browser, and on the right, I have a native app. So threats facing a browser in a phone is all your usual suspects: XSS, JSON hijacking, cross-site request forgery. You have a man in the browser, you have a malicious site, man in the middle. This is all standard stuff. Threats facing native apps. We have a slightly different landscape. We have things like intent spoofing, hijacking, cross-application scripting, permission leakage. Now you have these two sort of threat landscapes, and when you put them together, you get something slightly new. You get something more than just the sum of the parts. You get some new things that maybe people haven't thought about before. You take the threats facing the browser, threats facing the web view, you put them together, and you get something slightly different. So it's worth keeping that in mind. So first thing I want to talk about is the so-called JavaScript interface. So there's a pretty picture. JavaScript interface allows JavaScript to access Java objects in your application. So here's some code as an example. You call add JavaScript interface, you give the interface a name, and you supply your Java object. And in order to use that, you just need to put some JavaScript in your page to name the object and call a method. And that, in this way, you can call a public method on the injected object. Now, we should just make a note at this point that a JavaScript interface has no knowledge of the same origin policy. So really, this is a slightly dangerous feature, because if you can have untrusted content in the page, that can access the JavaScript interface. So back in 2012, people suddenly realized that you could actually completely abuse this. And the way you did it was to use reflection to effectively access any other Java object in the application. So for example, I'm using reflection, and I get a handle to the runtime, Java lang runtime. I get a handle to the get runtime, and eventually I call a method in the application. Here's another example. Down here, I can get hold of the telephony.sms manager, and I can send a text message. This was a well-known problem revealed back in 2012. So it's even worse. If you have code that's injected into your page, that code can do anything. It can access any Java object in the host application, can execute any Java code with the permissions of the host application. So this is, everyone is running around looking for JavaScript interfaces. So what Google did is they came up with a fix, and they said, well, from now on, you have to annotate your method. You have to put this JavaScript interface on your method. And what the runtime did was it made a runtime check. So if you try to access a method on an object and it wasn't annotated with @JavaScript interface, then the runtime would say, you can't do that. That's not allowed. So that's all well and good. But it comes with plenty of caveats. And basically, this thing only works if you're running on Android 4.2 and you've targeted API level 17 or greater. If you've targeted API level 17, you run it on an earlier device, you're still vulnerable, because the runtime doesn't know about this annotation. So you still have this problem on older devices. Okay? So you need to do other stuff. So, why am I talking about JavaScript interfaces? And a lot of what's in this talk is all public knowledge, but it's less well known. So is that the end of the story? Is that the end of the JavaScript interface story? So let me ask you a question. If I don't have a JavaScript interface, am I safe? So in order to make this demo go smoothly, I need to just read my notes. Let me just I've only got one shot at this. Okay, one shot. So, where's my, okay, so I'm going to load it. I'm going to go and visit a page. And it's worth pointing out, not that one. And in this page, I'm going to use the classic JavaScript interface reflection attack. Okay? What's interesting about this page is there's no JavaScript interface in it. That is the code. I have not inserted a JavaScript interface. Okay, I've said set JavaScript enabled, but there's no JavaScript interface. Okay? So, and what I'm going to do, I'm going to try the basic reflection attack. I'm going to write a file to mount SD card test. Just to like this. So I'm going to try and cat that file doesn't exist. Okay. Fingers crossed. Oh, let's turn it off. Have a look. Seems fairly benign. So it's loaded the page. Right. Catch that file. All of a sudden it does exist. So I exploited the Java. Let me repeat that. I exploited the JavaScript interface reflection attack even though I did not have a JavaScript interface in my application. So, yeah. So the answer to the question is, am I safe, is no, even if I didn't put one in there myself. Right? And what's the reason? The reason is the system actually puts them in for you. You didn't know that. It puts them in for you, and what it puts in, you won't even know about. So, there may be others. You just don't know. So even if you do one yourself, you may have JavaScript interface. So what you need to do, what developers need to do is they need some defense in depth. They need to say, remove that interface. And you do it for all the other interfaces. Now leave it as an open question. How do you know which interfaces to remove if you didn't even put them there yourself? That's a problem that's solvable, but we don't have time. No, it's yeah. Well, if you rerun your application, yes. Okay. So the next thing I want to talk about is the same origin policy and the file schema. That's quite a common paradigm for an application to load local assets, HTML assets. I mean, this is one of the use cases of a web view, right? You have local stuff and you have stuff on the internet. So you bootstrap the application, you have local assets. So here's an example. This is a really common thing. I say load URL, and I have a local asset. Okay? So what's the implication of this little bit of code? So what's the implication? I have a hint here that I need to do a demo. Let's go here. And I can't see it. Ouch. Right. Perfect. How am I going to do this? No. How much time have I got? Because I'm going to need a little technical hitch here. How am I doing for time? Sorry? 30 minutes still. 13 minutes left. More than 20. I've got a slight tech hitch which I did not foresee. Let's try something else. I'll go here. I want this one. A slight improvisation. I hope you can all still see the screen. here. Intercept on. Right. Okay. Hopefully we're ready to rock and roll. So I've got a file which just has, I'm going to go 1, 2, 3, 4, 5, 6, 7. So this is just to show you that, let's see if I can. Sorry? No, it's not that. I can do it without this if I. Of course, I did all of this before. I don't need this. Of course, I did all of this just before coming in here and last minute. So anyway, so I'm going to load a local asset as per the slide. And what that's going to do, here's the file I'm going to load. It's going to load other assets, and then it's going to pull some stuff off the internet. Okay. It's going to bootstrap off the internet. In this case, I'm just pulling, I'm going to, it's going to bootstrap. So double check that I have intercept on. I think I'm ready to go. Let's try. So load. Nope. This is the ultimate improvisation. Try again. There we go. Okay, let's try again. Again. Okay. Intercept is on. I didn't, but I don't know what's. Try again. Okay, so now I'm going to intercept. There's not enough space on this page. Oh, come on. Intercept the response. Yay. Action. Okay, so now I can forward. Yay. I'm going to replace my JavaScript with something else. Okay. At last. And forward that on. And we see what my JavaScript has done is it's managed to read the preferences file. Right? Now, why is that such a big deal? Why is that a big deal? Well, the implication of the fact that I've loaded something from the file scheme is that any injected script will have access to the same origin. What is the origin? What is the SOP for the file scheme? I mean, it's kind of ambiguous, but there's clearly a bug. They fixed it. Ice cream sandwich, and earlier you're vulnerable. But you can still, if your developer does this, they've turned on their unsafe behavior. They load a local asset, and you can inject some content. You can bypass the sandbox in a WebView. Now, the demo that I didn't get working is that this can work even if it doesn't load local assets. So, I'm going to skip this. Next up, I want to talk briefly about HTTPS. This is a good news story. The WebView does, the system does the right thing most of the time, as we'll see. So I want to talk about validating the cert chain, hostname verification, and cert pinning. Cert pinning is all the rage. There are plenty of other topics, very important topics, but don't have time. So let's talk about, firstly, validating the trust chain. I'm going to use the S sending a message to C to simulate server sending a message to the client. So when you do this, when the server does the server certificate, it offers a trust chain. Root CA vouchers for CA1, vouchers for CA2, vouchers for the end entity certificate. So how can this be attacked? Well, attack number one, did the verification actually check that I trust that root CA is trusted? So here's the attack. If you don't check, if the browser did not check or the WebView does not check that root CA was actually in your trust store, then I can provide a perfectly valid signed trust chain, and I can bypass it. Now, you'd expect a message, error, sorry, I do not trust the certificate. Another attack, did the implementation actually check the trust chain? Did it check each signature? So here, for example, root CA, CA1, I've slotted my own part of the chain in. This is not signed, as shown by the red arrow. You'd be surprised. This sometimes doesn't get done, like the Android fake ID vulnerability. Next thing is hostname verification. So I'm going to use the same thing. So in a sense, the client says, connect to myserver.com. Same thing, server gives a certificate chain. How can you attack this? Well, there's lots of man-in-the-middle attacks. You can DNS spoof, you can do all sorts of things. And what the attacker can do, I'm going to use the notation A of S for the attacker acting as the server in the protocol. So attacker acting as the server can offer a different certificate chain. This is rooted in root CA. This is a trusted CA. I just give a totally different chain. Or it could be nearly the same chain. And I can say, well, if I can do a DNS spoof, I can offer a different chain that ends in foobar.com. Now, if I only do that previous stuff, if I only check the chain, that'll pass. So the client needs to do additional steps that says, did I actually connect to foobar.com? Well, I didn't. I tried to connect to myserver.com. And the final thing is cert pinning. Well, cert pinning is basically saying, do I trust where this offer chain has been anchored? I don't trust the system store. I trust who I trust, the CA that I trust. Here's our example again. The root CA traditionally is in the system or user trust store. So imagine through social engineering, I can get a different CA inserted into that trust store, CA certificate. It's now trusted. And then I can mount an attack. Untrusted CA, CA1 prime, CA2 prime, signs myserver.com, that will pass. So what cert pinning does is it says, well, here's another attack. I could hack a CA. That never happens. Compelled creation, government goes and says, you must create an intermediate certificate for me. So with cert pinning, you maintain your own set of pins, and for example, the hack CA is not in the pins file. Now, after Jim's talk the other day, I went and had a look, and things like Turk Trust, Korean Certification Authority, Japanese government, those are all in the system trust store. So here's the summary. If you just do the default, these things work out of the box for you. Yeah, it's using the system trust store, certificate validation, hostname verification. They just work. If you roll your own, if you see someone rolling their own, that's worth testing because often they screw up. Certificate pinning is actually supported in 4.2 and later, but it's not easy to use. In fact, it's system-wide. There's no way to install your own pins. And there are solutions that try to do cert pinning in a WebView, but they're non-portable. They're problematic. So the million-dollar question is how to do cert pinning in a WebView. That's still an open question, although there's lots of information on the website about how to do it. Thanks. I think I'm okay, even with the slipper. Now, one thing I would say is everyone's running around saying, oh, you need to do cert pinning, you need to do cert pinning, you need to do cert pinning. Well, I don't know if you only need to do cert pinning if you're worried about some of these threats. Targeted malware, rooted phones, social engineering, HackCA. If that's in your threat model, do cert pinning. But if your app is findmycoffee.com, then there's no need to do cert pinning. And even Dropbox, this is one of my colleagues pointed this out to me. They have a bug bounty, and like number 2 or 3 of the list is they say, if you have a cert pinning finding against our app, do not call us. We're not interested. Don't give us a finding of lack of certificate pin. How much? 10 minutes? Did you give me 15 or 10? 15. Okay, so I think I'm doing better than I thought. Okay, so the final thing I want to talk about is URL schemes. So an app can register a scheme, scheme host path, and an app can be launched in response to some URL matching that scheme. Okay? So here's some examples. Telephone number, that might activate the dialer. Geo something, that'll show you a map. Mail to will invoke the app that's configured for mail. Nothing new. And the other important thing is when the system invokes something in response to a matching URL, does it through intents. So here's an example. If you do this, iframe source, telephone, blah, 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 you look at the log, you'll see an intent. And it says dialer activity, action view, show the dialer. So what's the big deal with schemes? Remember our threat model. Schemes create something new is possible now. Because if I can inject a malicious URL, something with a custom scheme, even remotely, I can turn your WebView app into an intermediary, and I can attack a victim. There are other things that need to happen, but this is something that can happen in the threat model. And I don't even need to be on the phone. I can just be remote. If I can do something on the network. Of course, if I'm on the phone, I can also do something similar. And I could even use a scheme to attack the app itself. Where here the app is the intermediary and the victim. So what's the big deal? And this is public knowledge. It's not that, I guess it's moderately well known. Even those custom URLs are invoked through intents. There's a special scheme for intents. And the great thing about this is that you have absolute control over all the stuff that goes in the intent. So I can say, the type, what action it is. I can even say where it goes. So here's a reminder for me to do the demo. So I need to set this demo up a little bit. Excellent. Nope. So So I'm going to go to a page. I'm going to turn on the unsafe usage. There's two ways to parse a URI. If I have a look, what's at this page? Here's my intent. It's at the intent scheme. And I'm going to say component equals, digital, am I allowed to? I don't know if I've violated the non-disclosure. But anyway, I'm going to send it to a private activity. A private activity in the app. So it should not normally be accessible. Don't know if I have that manifest. Yeah, it's not available. Okay. No, okay. So I'm going to send it to a private activity. So check that. Oh. There we go. So I visited a page. The page had a URL using the intent scheme, and I targeted a private activity, an activity in the app that's not normally accessible. Not too sure if I have that. Let's have a look. No, I don't have the manifest. Okay. That's fine. So there's some remediation guidance. Don't use intent.parseURI. But if you must, then do some stuff. This is the original paper. What am I doing for time? Okay, well, I'm going to finish early. Good. So, in summary, we've looked at a few facets of WebViews. Looked at JavaScript bridge, looked at same origin policy, looked at HTTPS, scheme handling. So some takeaways from this. It's not just what the developer coded. It's not what was coded. Sometimes even what was not coded. Same origin pipe bypass within the WebView normally doesn't mean a sandbox bypass, but it can mean a sandbox bypass. You can end up getting access to the file schema. That's bad. If you do the basics, you don't roll your own HTTPS stuff, you're probably okay. If you findmycoffee.com, you're okay. If you want to do cert pinning, that's a hard problem to solve. And a WebView is potentially a proxy, your WebView app is potentially a proxy to other apps, to attack other apps, or even itself. So you've enabled a remote attack. You have to do things in a WebView. It doesn't just happen automatically, it happens in the browser. Most developers want to be user-friendly. They see a link for a PDF, they dispatch it because it makes their app user-friendly. So usually they do this kind of stuff. And with that, thank you very much for listening. If there are any questions or not. So what we recommend for critical apps is to avoid using a WebView. If you do use a WebView, make sure that no untrusted content gets into that. So you may have additional controls. So I think it depends on the risk. But generally, critical apps, if you're going to use a WebView, be aware of the risks. Have a private app tunnel, something to take additional controls to make sure that no uncontrolled content, because if uncontrolled content gets into the web view, there's usually something that allows you to do something you shouldn't. So I wouldn't recommend it for high critical apps. But if you're worried about that kind of thing, you're probably doing other things anyway.
So to continue that, for a private app tunnel, that could be this NDM type of thing?
Well, I was just throwing that in. I threw that in loosely. Yes, that kind of thing.
Yeah.
That kind of thing, yes.
Okay, would that also apply to applications like Sentia, XJS? Are those WebViews too?
I'm not familiar with those.
So those are used in enterprise for enterprise development.
If it's something like, if it's a framework and it's based on the WebView, then I'm not familiar with those frameworks.
So I'm an Android group, so I don't know anything about it, but within an app, how does pinning work? In the browser, you have
I'm so glad you asked that question.
some kind of cache.
Okay. I had some extras. So if you want to do pinning, you're using the Java Secure Sockets extension. It's fairly easy to do pinning. What you do is you have your own trust store, certificate trust store, in the app. You load it, and you give it to the socket factory. You say socket factory, and you give your own trust store, and you can use that socket factory then to create your own SSL sockets, and that will use your certificate trust store. So the server needs to give you a certificate that's in that trust store, and it'll do the right thing.
Good. Got that. It's safe now in the trust store. What if the certificate expired there?
I'd have to go and check. So there are, I'm pretty sure it checks expiry, but I'd have to qualify that. There's some things that are not checked, that I know are not checked. For example, the basic constraints in a certificate. That won't be checked. If you have a CRL distribution point in the cert chain, those won't be checked. Pretty sure the expiry will be checked, but I'd have to go away and double check that.
Let's say we have an application which is called Drizzlebox, right?
Yeah.
And that does certificate pinning.
Mm-hmm.
So,
Well, how's it doing the pinning? Is it doing something like this?
you do the pinning this way.
Yeah.
You have the pin in your certificate store.
Mm-hmm.
Then on the server side, you change the certificate.
Right.
So how does next time does the application needs an update? Or
I think it pins to the subject public key info. So if you issue a new certificate, you're fine.
okay, or is there a chicken and egg problem? Because
Yeah. Well, you can. I think Jim was answering this question yesterday, because if it's expired, then you've dosed yourself. So you need a mechanism to replace the pin, swap a new pin while the old one's still valid.
exactly that's I'm referring to.
Yes.
I was wondering whether this
There's no standard way of doing it. No. You need to manage it yourself. That's why cert pinning is like a big undertaking. It's not just pinning. There's all the infrastructure that goes with it.
artifact is seems to be more difficult with an apps as with the browser.
Yeah, the browser's relying on the system trust store, and you're getting other things with later versions of Android. You're getting blacklisting, for example. Of course, the blacklist has to get onto the phone, but it caches. So you're getting additional things. You have to manage that yourself.